Good afternoon, everyone, and welcome to the Northeast Aquatic Plant Management Society's 2025 Winter Webinar Series. Today will be session 1, which focuses on harmful algal blooms. So before we get started, I have a little bit of housekeeping to go through. See if I can get my slide. There we go. So I just want to tell you a little bit about the Northeast Aquatic Plant Management Society, or NEPMS. Our mission is to assist in the management of aquatic vegetation, to provide for the scientific and educational advancements of members, to encourage scientific research in all facets of aquatic plant management, to promote an exchange of information among members, and to extend and develop understanding in the discipline. Our members are from academia, government agencies, private consulting firms, herbicide manufacturers, and lake associations. We have annual meetings, annual plant camps, webinars with CEUs, and we offer student scholarships up to $10,000. If you'd like to learn more about the Society, please check out www.neapms.org. So today's webinar is set to run from 1 to 3 Eastern Time. There will be 4 presentations with a block of 25 minutes at the end for questions and discussion with presenters. Please type your questions into the chat box and the moderator will read them during the Q&A session. Please note that we are not able to offer CEUs for this particular webinar. The webinar will be recorded and it will be shared via link on the NEPMS website. More information to follow on that. And here is just a breakdown of our speakers for the day. First speakers will be Blake Schaefer and Max Beal from US EPA. Next up would be New Hampshire's Kate Hastings, and then New York State DEC's Brian Duffy, and Chris Kunz, I hope I pronounced that correctly, from New Jersey's Department of Environmental Protection. So, whoops, go back. Without further ado, I'm going to introduce the 2 speakers for today. Who'll be talking about harmful algal blooms, satellite monitoring and forecasting. So Blake Schaefer earned his PhD in Marine, Earth, and Atmospheric Science from North Carolina State University studying harmful algal bloom ecology. He is currently with US EPA and researches the applied use of satellite and sensor remote sensing technology to monitor water quality in coast, estuaries, lakes, and reservoirs. Max Beal earned his PhD in Civil and Environmental Engineering from the University of Wisconsin-Madison. And he is currently, focused with his research focusing on hydrology, climate variability, and water quality. He is currently a postdoctoral researcher with US EPA, and he is working to develop national cyanobacteria forecasting capabilities for freshwater lakes and reservoirs. So I will stop sharing. Oh, it's already not shared. Okay, and leave the presentations to Blake and Max.
Thank you so much. We appreciate the introduction, and thanks for everyone and their interest in our work. Can you hear us okay? Just as a quick check.
Yes.
Yep. Excellent. All right, let's see if we can get the presentation lined up. All right. Thanks again. My name is Blake Schaefer, and I am happy to introduce Maxwell Beal, a new postdoc in our lab, who will discuss the future forecasting ideas that we have. First, we're going to start with an overview of our ability to monitor cyanobacteria directly and real time in federal, state, tribal, and local partners in their mission to protect aquatic, animal, and human health. Every day, a satellite named Sentinel-3 scans these lakes, pinpointing the exact location and timing of the cyanohabs. And the best part, within 24 hours, that is everyone here today listening on to this webinar, can access the satellite data and see where and when cyanohabs are occurring in the largest US lakes. The Cyanobacteria Assessment Network has put the power of satellite technology into the hands of the public. So you might be wondering, how do the satellites detect cyanobacteria? And just to keep things simple, we're going to just clarify that they measure changes in the lake water's spectral color. So imagine when you're on one of our pristine blue lakes and it turns bluish green from the cyanohabs, the satellites catch that color shift and can alert us to those detections. You can check out the daily coverage example on the left. Now, if we were to replace these satellite observations with traditional methods, it would cost an additional $5.7 million annually. So this means to replicate the satellite's daily observations with scientists sampling every lake every single time a data point was available would take an additional $5.7 million per year. So we all know the frustration of needing to be in multiple places at once. Similarly, monitoring every US water body all the time with limited resources is a tall order. So enter the satellite technology. It complements traditional field measures and offers extensive spatial and temporal coverage. EPA is part of the 2014 Harmful Algal Bloom and Hypoxia Research and Control Act. And this act underscores the need for advanced monitoring and forecasting of cyanoHABs in US waters. With Cyan, we've demonstrated that earlier response and informed decisions are not only possible, but can save money and protect our health. My father always said illness never comes at a good time. So let's kick off with a powerful example of how we safeguarded a community's health and kept everyone on the job from this project. Utah Lake is a recreational hotspot for swimming and boating. It's known for occasional cyanoHAB events. Resources for the Future conducted a study in Utah where our satellite imagery detected a bloom that traditional field sampling missed. Leading up to the 4th of July holiday, local officials were on high alert for cyanoHABs to prevent illness. Just weeks before the holiday, satellite imagery identified the onset of a cyanoHAB as shown on the left. The cool purple and blue colors indicate low concentrations, while the warm yellow and oranges signal higher concentrations. Local officials confirmed the cyanoHAB and issued an advisory, ultimately protecting human health and saving $370,000 in healthcare costs for just a single event. The day before the holiday, you can see the bloom spread across the entire lake as demonstrated on the right. The project offers 3 software tools that are tailored to different user needs. CDAS is NASA's open source freeware. It is ideal for detailed analysis and supported by an active online community forum. RS Tools is a NOAA plugin for ArcMap or more recently ArcPro. It's available for any of those folks who work with Esri software licenses. Our focus has been on the Cyan web app, which offers similar functions for the users, but without the time and expertise needed to do detailed analysis and data downloads. We have provided numerous trainings through YouTube videos that are available on the web for free and various webinars such as this one, ensuring that everyone can use these tools effectively. Cyan also provides annual metrics for quantifying what is happening in a lake or a region, including the temporal frequency, how often do these blooms occur, the spatial extent, how much area do these blooms consume, and the occurrence rate across 2,192 lakes. So how often do we get a detect of a bloom across all of these lakes? Soon, we will also offer the magnitude, which is what is the average concentration over a season. And these metrics are publicly available on EPA's EnviroAtlas and reports on the environment. So real-time data, training, software, and annual metrics all contribute to the comprehensive cyanoHAB information. But how has all this data been validated? So we don't have a lot of time today, and I'll just highlight one specific example. We have validated the satellite data using information from states, nonprofits, and federal agencies, including state advisories, chlorophyll measures, and toxin levels. For example, we matched publicly available state cell counts and toxin measures with satellite measures as mapped on the left. We have 84% overall agreement with those measurements and the satellite data. The misfits often occur due to factors like cloud cover, which interferes with the satellite imagery, or bloom movement and dissipation throughout the day after field sampling. And I do want to clarify, in this imagery, we're detecting just the biomass. We do not have the capability to detect toxin concentrations from satellite. There's no optical signature that's available when toxins are produced that is needed to be detected via satellite with these methodologies. So the next question might be, who uses this satellite data? Usage is tracked through state documents, news reports, social media posts, and guidance documents. State documents now citing satellite data include the Interstate Technology and Regulatory Council, States like Wyoming, New Jersey, California, Idaho, Oregon, and Louisiana explicitly reference cyan information. Tribes like the Seneca Nation and Coeur d'Alene tribe have benefited, as shown in news reports and EPA nutrient criteria projects. Local lake associations and international organizations like the American Waterworks Association and World Health Organization also now recommend satellite data and the cyan methods. So our focus in the overall introduction has been on current cyanohab monitoring of current occurrences. But we want to do better. We want to look at forecasting these bloom events, which is even more critical. So we've developed a forecasting model similar to how the weather is forecasted, providing weekly probabilities for lakes to exceed a 12 microgram per liter threshold. Our model predicts the probability of exceedance for each lake as shown on the right, with purple indicating low probabilities and yellow showing high probabilities. For 2021, the highest probabilities were from July to September, particularly in the southern, upper Midwest, and Southeast regions. Our model achieved an overall accuracy of 90% from 2021 through 2023. I should mention that the original Cyan project worked so well because the HAB coordinators helped us engage with states and looked at the data in their local areas and provided us some direct feedback. And this feedback loop is really critical because the local folks are on the ground with their local water bodies. And we would really like that partnership to continue with the HAB coordinators and folks on the ground for this new forecasting ability. And that way it can inform us how we're doing locally, and we might be able to make improvements or refinements going forward. So EPA excels in collaborative science for the public, and our Office of Research and Development partnered with the Office of Water to make these forecasts operational within a year. So if you follow the QR code, you can see the beta test forecast website. Our office developed the science behind the forecasting model, and then the Office of Water operationalized it. So they were running it every single week to provide the forecasts publicly. We made this transition from a research science paper to a public release of information in just under a year. The website, if you go to it, is undergoing updates in preparation for the 2025 HAB season. So we typically take the winter months when there's not a lot of presumed activity to kind of retweak our tools and our interfaces and try and take feedback to make things better for the next year. And we'll be back forecasting, we estimate sometime around April, just in time for the early onset of bloom season. On the left, we provide an example of one potential update we're considering to use a stoplight coloring system. On the right is an example from the forecast this summer. We've just picked out three examples of three different lakes in September, where a low probability bloom in Pleasant Lake is green with a less than 2% chance of a bloom. The satellite image for this lake confirmed no bloom occurred later that week. And we see this because if you look at the lake area, it's all gray, and those gray pixels indicate to us there are no detections of cyanobacteria from the algorithm. The satellite image confirmed this, and then we move on to a high probability bloom that was forecasted for West Lake, Florida, with over 90%. And the satellite imagery later that week confirmed the bloom was detected. So you can see in the center panel here, there are green pixels throughout the entire lake. So there's a pretty decent bloom that's occurring later that week that was forecasted with high probability. And then finally, there's a moderate probability of greater than 10%, which suggests a bloom may form in Lake Hefner, Oklahoma. And the satellite imagery confirmed, whoops, sorry about that. I clicked the wrong part in my computer. Let's try this again. There we go. It's a satellite confirmed that there were detections in that lake. Maybe a bloom is just getting ready to start, but you can see it's not throughout the whole lake. So now I'd like to turn it over to Max, who will discuss some of our recent advancements and thoughts regarding forecasting next steps.
Hey. Hi, everyone. So again, I'm Max. I'm a postdoc working on some of the next steps for the cyan forecast that Blake just introduced. So what we're thinking about moving to is moving from this lake level approach, which Blake just introduced, down to a pixel level forecast. And so as mentioned earlier, the Sentinel-3 imagery has a 300 by 300 meter resolution. And you can see an example of that in the image below, which shows all of the lakes across Florida, which is currently the test site for this new forecast, and then a call out of one of the lakes with each of those pixels highlighted in green there to give you kind of an idea of how many pixels are across each of these water bodies. So we're currently targeting developing a forecast that would, again, just forecast out 1 week of chlorophyll A biomass in these lakes. But we're also planning to look at some longer lead forecasts at 2 and 4 week leads to try to extend some of our capabilities. So these will also provide weekly probabilities of exceeding these World Health Organization alert level threshold. So that's 12 micrograms per liter, and then at the alert level 1 and 24 micrograms per liter at alert level 2 in each pixel in each lake. So the real benefit of having this pixel level forecast is it helps us zoom in and capture some bloom events that might be lost when you look and aggregate satellite information across a whole lake. So just looking at Florida, we actually find that we're able to capture these smaller bloom events that might just occur in a portion of a lake, and also more transient bloom events that might kind of pop up and last for a couple weeks and then disappear, but are still potentially harmful to human health. And just across Florida, we're actually finding that when you look down to this pixel level, you can capture 5,000 more bloom events that were previously unseen at the entire lake scale. So just to give you a little bit of a peek at early results here, we're seeing promise with this forecast. So our forecast that's under development for Florida is currently showing 87% accuracy at this alert level 1 and 92% overall accuracy at alert level 2. And I've just included 2 figures here of the pixel level accuracies across all of our lakes in Florida here for alert level 1 and alert level 2, with just a couple of call outs here. And just highlighting that, pixel, there is variability in forecast accuracy across each of these pixels. And that's something that we are looking into, but overall seeing very, very strong accuracy in this forecast at the pixel scale. And so something that I would love to get all of your feedback on at the end of this presentation here is thinking about a little bit of what kind of forecast types and lead times would be most useful to you all in monitoring and management of water bodies. And so what I've done here is come up with 2 conceptual models and really put these into 2 bins here. So on the left-hand side, we have this continuous forecast, which is pretty much what we have now. So this is just a forecast like a weather forecast where you'd look out 1 week, what is the forecasted probability of a bloom? We could forecast out 2 weeks, what's the forecasted probability, and then 4 weeks, looking at different lead times, but issuing a forecast each week. The other bin here over on the right is a seasonal forecast. So you might have heard of the seasonal forecast for Lake Erie. And these are forecasts that really just issue 1 forecast for an entire season, looking at the peak season for cyanobacteria biomass across a water body. And so what you do is you tend to look at throughout the springtime, March through May, what are the conditions of the water body and the watershed, and use all that information to forecast, something like what is the % chance that we're going to see above normal cyanobacteria productivity on this water body throughout an entire season. And so I'll just emphasize here that for the seasonal forecast and the continuous forecast, you're really forecasting some different values at a seasonal scale, really looking at an average or some metric that really captures cyanobacteria productivity across an entire season. So again, if you all just think about that, we would love to hear what kind of feedback you might have on these kinds of forecasts and what might be most useful for management. So tagging on to some of the forecasting work here and looking ahead, we're working with the U.S. Army Corps of Engineers and other existing federal partners to focus on higher resolution detection of cyanobacteria with Sentinel-2 imagery. So Cyan operates at this 300-meter pixel resolution, and Sentinel-2, which is another satellite, will then provide 20-meter pixel resolution. And this will take us from seeing just a couple thousand lakes across the US to several 100,000. And then this enhancement was really universally requested by the states. So to give you an idea of what that looks like, our coverage here seen on the left with the current Sentinel-3 Cyan product is 2,192 lakes. And that will increase on the right to over 270,000 lakes moving to Sentinel-2 and nearly all estuaries. So the cost to replicate Sentinel-2's observations using traditional methods would be $42 million a year. So this means replicating the satellite's daily observations with scientists sampling every lake would take an additional $42 million a year, which really, I think, highlights the potential value of this technology. So just to finish up here, I just want to acknowledge the team who's contributed to all of this work and the collaborators who provided feedback, as well as the funding programs. I'll also just note that the views expressed in this talk are ours alone. But really, thank you so much for your time and interest in this work. And we would be happy to answer any questions or hear any feedback.
Thank you both. We will hold questions until the end. So if you have any, please put them in the chat. And next up, we have New Hampshire's Cyanobacteria Harmful Algal Bloom Monitoring Program with Kate Hastings. Thank you, Kate.
Great, thank you so much. Can you hear me okay?
Yes, we can.
Awesome. All right, let me just adjust here.
While
Yeah,
you're,
so, oh, yep, go ahead.
I was going to say, while you're adjusting, I could read part of your biography.
Okay, thank you, sure.
Okay, so Kate studied at the University of New Hampshire, earning her MS in biology. With Dr. Jim Haney in the Center for Freshwater Biology, her research focused on the aerosolization of cyanobacteria cells and toxins as a novel route of exposure. She is currently working as the New Hampshire Department of Environmental Services Cyanobacteria Harmful Algal Bloom Coordinator since April 2022. Thanks, Kate.
Sure, thank you. Great, okay. Perfect. Okay, so thank you for the introduction. Today I've been tasked with providing a bit more of a background on cyanobacteria, so we'll start with that. And then I'll review New Hampshire's cyanobacteria monitoring program specifically, and then trends that we've seen in cyanobacteria over the years through collection of data through this program. So starting with the real basics, hopefully this isn't too much of an overview for too many of you, but cyanobacteria are naturally occurring components of our freshwater ecosystems. They typically exist in balance with other phytoplankton in our systems and take their turn throughout the year in being the more dominant form of phytoplankton present in an ecosystem. Unfortunately, many of our ecosystems, our freshwater ecosystems, are becoming imbalanced due to anthropogenic, so human-caused issues. So a lot of them are having excess nutrient loading, and climate change is affecting them as well. And in many cases, cyanobacteria are so good at what they do, they tend to be the ones that take advantage of these imbalances and grow out of control into what we call blooms. So as far as excess nutrients go, a lot of these nutrients are coming into our water bodies through precipitation and stormwater runoff. So that can be through just general urbanization, so development of our watersheds, which we all see a lot of. Agriculture and livestock can bring in nutrients, and then just residential areas as well. So with stormwater runoff off roofs and driveways, off those beautiful green lawns we see coming up to the water's edge, and from failing or unmaintained septic systems as well. And then climate change is a big factor. So our atmosphere is warming, which means our surface water temperatures are getting warmer, especially the epilimnion regions. We're seeing shorter periods of ice cover in New England. And we also have thermal stratification lasting for a longer period over the year, which means that we are having more times of anoxia at the bottom of our lakes, which can be ecologically problematic, but also create a situation where we can get phosphorus coming unbound from sediments and entering the water in a form that's available for phytoplankton, but particularly cyanobacteria are good at taking up that phosphorus at that point and growing out of control into these blooms. In New England, climate change is also contributing to changes in precipitation patterns. So instead of more regular storms, we're getting longer periods of droughts, and then these huge storms that bring in big pulses of nutrients all at once. Which is just a change. And because cyanobacteria have so many of those competitive advantages, they tend to have the edge over other phytoplankton and take advantage of those nutrients and grow into these blooms. So blooms overall are very dynamic. These pictures highlight how dynamic they can be in their physical appearance. So all sorts of colors and textures. They also have variability as far as the time of day that they show up. They can also move around a water body based on wind, wave, and boat action. And then the length of blooms is also extremely variable. So some of these will pop up on our water bodies for a day, and sometimes they'll persist for entire summer seasons. So blooms are inherently bad because they can cause ecological damage. When the biomass of a bloom dies off, that process of decomposition takes oxygen out of the system and can make it uninhabitable for other aquatic life. But there's also the issue that many cyanobacteria are capable of producing toxins. And when they bloom, those toxins can be in elevated enough concentrations to cause health issues for humans and wildlife and our pets. So on top of blooms being extremely dynamic, the toxicity, so the type of toxin and the amount of toxin, can also change rapidly over the course of a bloom. There are many different cyanotoxins. So to name some of the major categories, there's neurotoxins, hepatotoxins, cytotoxins, genotoxins, dermatoxins, and tumor promoters. Symptoms as a result of exposure depends on the type of cyanotoxin as well as the amount of exposure, so the quantity, but also if it was an acute or chronic exposure, and then the route of exposure. So symptoms can range from mild to severe, so from dermal, eye, nose, and mouth irritations, general malaise, fever, nausea, vomiting, diarrhea, gastroenteritis, tingling, numbness, and seizures, and in severe cases, nervous system and organ failure and death, which is much more common to see in animals because they're more likely to ingest enough of the toxins to see these results. In recognition of two cyanotoxins, the EPA has established recreational use guidelines as well as more strict drinking water health advisory guidelines. Our focus in the recreational world in New Hampshire is on the mostly microcystins, and that is the 8 micrograms per liter level. So as far as routes of exposure to cyanotoxins go, the primary route of exposure is through drinking water, so contaminated drinking water supply, but you can also get exposed through recreation. So even as adults, you can't help but consume some of the water that you are swimming in, but this also puts kids who are learning to swim at risk for ingesting a bit more of this. Our food sources can also become contaminated. So we know that to varying degrees, different cyanotoxins can accumulate in fish tissue, as well as vegetable tissues, or just be on the surface of vegetables from their irrigation sources. And then some people take cyanobacteria supplements or are adding cyanobacteria to some of their food, like smoothies and other green drinks. So the FDA has started regulating these food products for microcystins specifically, and they do pretty frequently issue recalls for high levels of microcystins. So if you enjoy an occasional green beverage, take a peek at that website and pay attention to it. Inhalation is a potential secondary route of exposure. This can just be from recreating on a lake, but also I know in a lot of places across the country, people do shower with lake water in their lake houses. Can also be through skin contact or eye contact, so swimming, boating, recreation, and then just aerosols in general. So microcystins, as I mentioned, is really our focus. It is the most common cyanotoxin found worldwide, but also in New Hampshire. It's a potent hepatotoxin and tumor promoter and can cause both acute and chronic toxicities. Unfortunately for us, microcystins are extremely stable compounds that can persist in the environment for 4 to 14 days, even after the cells that have created them have degraded. So you no longer have the visual cue that they may be present in the system. This figure on the left here from the paper I've cited, I think is helpful. We think of microcystins as a liver toxin, but this highlights all the different systems in the human body that it can have an effect on. So the lungs, the liver, the immune system, the stomach, the small intestine, and the colon. And unfortunately for us in New Hampshire, 3 of our most common bloom-forming taxa are capable of producing microcystins. And again, we do see a fair amount of this toxin. So shifting gears here and talking about how we are specifically monitoring for cyanobacteria across the state of New Hampshire. So we run a response-based program, which means we're not doing any routine sampling anywhere, but when folks let us know about a potential bloom, we'll go there and sample and communicate about it from there. So we're really trying to emphasize the concept of what we're calling a self-risk assessment. So teaching people that they can arrive at a lake edge and look at the water and visually decide if it's safe or not to swim based on the visual presence of cyanobacteria. And then also pairing that visual assessment with staying informed with our resources and all the information we're putting out there about when we do know when blooms are occurring. So a couple years ago, we implemented a new bloom report form. We're using Survey 123, which has been super helpful. Prior to this, people would report blooms by calling us or emailing us or just texting us a picture. So it was a little chaotic, but this has really helped streamline the process. So it's a cool form. It's adaptive, so based on how you're answering different questions, you'll get different information. But it really just standardizes the information we get. You know, where on the water body it can take a GPS location if people allow it, specifically what coves they're seeing bloom material in, all sorts of general information when it's occurring, etc. We can have people upload photos directly through this form, which is very helpful, and then just get general water body information. So is there public access? Is this a drinking water supply, for example? And then we always ask folks if they're able to get a sample for us. Which can be really helpful, but we end up doing a lot of sampling ourselves too. But if folks say that they are able to help us sample, this form will give them the instructions on how to do that safely. And then obviously collecting reporter information. Another great feature about this form is it will tell people when they can expect to hear from us, which is always helpful, and then give them links for information to pursue until they do hear from us so they can continue their education. So once we get a sample, our program is really focused on microscopic analysis. So we identify and enumerate what cyanobacteria is present. We have a state recreational threshold for based on a cell count, so that's 70,000 cells per mil. And this has, through studies, been related to the EPA microcystin recreational use guideline of the 8 micrograms per liter. So the reason we're running this program based on microscopic analysis is it is a faster turnaround time. It captures the risk of multiple toxins, and it's more affordable than doing toxin analysis. We do some toxin analysis on the side. We take subsamples during the growing season and then run those in the winter. So there are obviously limitations to this. It's expensive to run these tests. They're very time intensive, and we feel the results on the scale that we are running this program would be too delayed to inform public health in a meaningful way. And there's also many different cyanotoxins. So each test has to be specific to the toxin that you're interested in looking at. So just some complications there for toxin analysis. So going back to our cell count, we kind of have a 2-tiered approach and are using that stoplight approach as well. So if the cell count is below but approaching that recreational threshold for New Hampshire, the 70,000 cells per mil, we may issue what we call a watch. We also use these if the bloom has passed by the time we get a sample, or if we only have a photo on a Friday afternoon and want to get the word out there but haven't had time to look at a sample yet. So we will resample if we issue a watch. Only if folks are reporting continued worsening conditions, and then they're active on our map for a week. Then if the recreational threshold is exceeded, we issue what we call a warning. So this is a lake-wide warning that the water may not be suitable for wading or swimming if bloom material is present. And if we issue a warning, we commit to weekly resampling until the bloom has passed. With our resampling, we try to collect samples under representative conditions. So if it's raining or really windy, we'll probably wait another week to lift the warning to make sure it's representative of what's really going on. As a note, we don't close water bodies, but we do advise against recreation, reminding folks that children and pets are the most vulnerable. So over the last couple years, we've also been refining our map resource as well. So kind of created an overhaul. This has been a great resource. The public really likes it, and it's very well used resource across the state of New Hampshire. So we're able to link about a bunch of our other resources off of this page. We have a summary panel on the right side that lists where our current watches and warnings are. You can also see the symbols of where those warnings and watches are on the map. And if you don't see a symbol over your water body, you can always search for whatever water body you want as well. So if you click on that water body from the right side or you're searching for it, it'll zoom you to that spot on the map, and a dialog box pops up that has a bunch of different information. So when we last sampled, what the status is for the water body, when the warning was issued, bloom description, what was identified at what density. If there had been previous warnings in that growing season, we list those dates and then have a link to the full history for that water body based on our data from over the years as well. We also really helpfully include pictures of the bloom, so folks can know exactly what they're looking for if they are trying to recreate on the water body, they know exactly what to watch out for. And then we also have a link for folks to sign up for water body specific updates. So we share this information with these groups immediately, and this has been really helpful in targeting specific communities that need more detailed information. And then we also lean on them to inform our resampling efforts. So we'll ask folks where they're seeing updated bloom conditions and use that to inform our sampling locations. This past summer season, we had 2 big lake-wide events on our biggest lake in New Hampshire, Winnipesaukee. And at that point, we realized our map could use a bit more resolution to help address folks trying to understand their risk around blooms. So we added specific bloom points on top of the map so folks could see where those were happening. So each of these, again, if you clicked on one of those points, you'd have a dialog box pop up with a picture. And if we had done corresponding sampling, those results would be there as well. So really helpful resource with lots of information on it. And now jumping into my final section here, discussing cyanobacteria bloom trends over time. So since this program's been operating from around 2003, 2004 to all the way through last year, we've issued at 127 different lakes. Unfortunately, we do recruit new lakes in New Hampshire to this list every year. As you can see from the map, we've issued from north to south, east to west, but primarily we're seeing cyanobacteria issues in the more southern part of the state. This is partially due because that's where the people are to report them to us, but also our watersheds are much more developed on the southern parts of the state. So this graph here is showing you years of operation on the x-axis, and the bars are the total number of warnings or watches. The warnings are red bars and the watches are yellow bars. The fewest warnings we've ever issued in a year was that first year, 2003, just 1, and the most was in 2023, so 69 warnings. In 2020, we started issuing watches kind of in response to the pandemic. We just wanted to be able to get information out even if we weren't sampling. So that's been a really helpful tool that we've kept around since then. So fewest was 34, the most was 2021, kind of coming out of those pandemic years as well. I think over the last few years, we've kind of evened out with our program capacity and being able to do a bit more sampling on the ground. So the number of warnings and watches have kind of balanced each other. So some water bodies in New Hampshire do have multiple warnings and watches per year. So to show you that, last year we had 66 warnings in total, but only at 43 water bodies. We have seen a statistically significant increase in warnings since 2003. And of course, a lot of this is likely driven by those 2 factors I talked about at the top of the presentation, but so eutrophication and climate change. But it's also important with these data to recognize that this is a reaction-based program. So samples are really primarily collected when they're reported to us. So the fact that we have had increased public awareness means we get more reports, and more reports means more warnings, which kind of seems like a bummer, but overall we hope warnings are keeping people and pets safe. So we're glad people are still reporting and using our program and knowing what to avoid. As far as seasonality and duration of cyanobacteria events in New Hampshire goes, we're showing different months that we've issued cyanobacteria warnings in the state of New Hampshire on the x-axis, and the bar is the total that have ever been issued in those months over program duration. So We've issued May through October, primarily during the peak summer season, when the water's warm enough for the cyanobacteria to really do their thing. We do have to acknowledge that colder temperatures means less recreation, and that, people go back to different homes and kids go back to school, so less recreation means fewer reports. So we could be underestimating bloom occurrence at those time of years. We do know that cyanobacteria are so good at what they do bloom under ice, and this is something that we have seen in New Hampshire as well. As far as duration goes, over the last handful of years, blooms persist for 24 days on average, though quite a range there. So shortest was 2 days and the longest was 132 days. Based on the way we're doing sampling now, they tend to last around a week at the beginning of the summer, and then as the summer progresses into late summer and early fall, the blooms can really persist for a long time. And then, of course, everyone wants us to be able to predict how long they may last, but we remind folks that it depends on the water body, the current nutrient inputs, the legacy of nutrient inputs, and the weather, of course. So returning to some cyanotoxin data. So this graph here has a lot going on, but we'll focus on 2023 to break it down together. So the total bar is looking at the total number of warnings that were tested for microcystins in that year. So 68 in 2023. The green portion of the bar is the portion of warnings that did not have any microcystins present in them. The yellow portion had microcystins present to some degree, and the red had microcystins above the EPA's recreational guideline. And then the percentage on top of bars is the percent of warnings that had microcystins to some degree in the initial samples. So the percent of warnings with detectable microcystins has varied from 50 to 75%. The percent of warnings with microcystins above the EPA threshold has really ranged from just 3% to 42%. 2023 is the last year I have fully analyzed at this point, but that was around 18%, so a little bit more middle of the ground there. But these data are really just looking at the initial bloom sample, and we do know that bloom toxicity is dynamic, as I mentioned earlier, and that it can change over the course of the bloom. So that's just something to keep in mind. And the fact that microcystins are not the only cyanotoxin. So this chart here is going to demonstrate that point. So looking at a subset of 2022's toxin data, just listing out a portion of the warnings or advisories that we issued that year, the dominant cyanobacteria that we found in those warnings, and then these columns here correspond to different cyanotoxins. So the microcystins is that MC, cylindrospermopsin is the other toxin the EPA has established guidelines for, and then ATX is anatoxin, so one of the neurotoxins that cyanobacteria can produce. So those columns will populate with different colors. If it's green, it means that warning had below detectable levels for that toxin. If it's yellow, it means the toxin was present. And if it's red, that means it was above the EPA's guidelines, which can only be true for microcystin and cylindrospermopsin. So these are the data here. Just to highlight a couple of different scenarios here, we do have some warnings where just one toxin was present, around 30% that year. We also have a subset that had two toxins present, so 40%. And then we have some warnings that have all three toxins present, so 31% that year. So just interesting to look at. This year in particular, there were no warnings that were completely cyanotoxin free, so also interesting. So hopefully this helps illustrate why in New Hampshire at least we're issuing warnings based on cell count in hopes that we are capturing the risk associated with more than just one toxin. So I will leave it there for now. Thank you all so much for listening. Happy to take questions at the question and answer period at the end. Thank you.
Thanks, Kate. So next up, we have harmful algal blooms in New York State, strategies for monitoring and protecting water resources with Brian Duffy. So Brian is a research scientist and section chief for the monitoring and assessment section in DEC's Division of Water. He received his BS from St. Michael's College in Vermont and his MS from SUNY Albany. He has a background in bioassessment, water quality monitoring, and applied research to advance management of water quality resources. Take it away, Brian. Thank you. So Brian, I think you're still on mute.
How about now?
You're good.
Okay, great. So when I shared my screen, I lost track of the unmute button. So thanks for the intro, Kathy. I think I'm the section chief, as you mentioned, for the monitor and assessment section. You know, as part of that section, we manage several programs overseeing surface and groundwater programs across the state. Ponded waters, flowing waters, like I said, groundwater, and a big part of what we do every year is manage and monitor for HABs, right? In the New York harmful algal bloom system is a big part of that, the NIHAB system for outreach and reporting. So all the presentations that we just heard were a really good primer, and I think you'll see some similarities with what we've got happening in New York State. So I'll get right into it. Real quick, the outline, what I'll talk about today. Briefly touch on the HAB background in New York State. The previous presentation was really helpful in laying the groundwork. A couple slides on how we look at HABs in New York. I'll touch on some applied research and how we've applied that research from a management perspective and how we've evolved our programs. And then I'll leave off briefly on the path forward and kind of the big picture long-term strategy in terms of a HAB roadmap for managing HABs in New York. All right, so no secret, HABs, as we've been hearing, have been increasing across the world and across the US in recent decades. In New York State, between 2012 and 24, we've confirmed freshwater HABs in over 650 water bodies. Each year, that list of water bodies grows by about 50. And in response and as a result, in 2019, we implemented the New York harmful algal bloom system, which or NIHABs, which is similar to what we've previously heard from New Hampshire. It's a ESRI Survey 123 based platform based on visual observation and reporting. And it also, in addition to helping communicate and inform the public about where and when HABs are occurring across the state, it's an important collaborative tool or interagency collaborative tool between ourselves at DEC, our Office of Parks and Recreation, Historic Preservation from a beach management and recreational protection perspective, and as well as our Department of Health in helping to inform and manage drinking water supplies across the state. Few brief comments on the challenges of managing HABs. As we heard previously, it's been well covered. Highly specialized, competitive, ancient microscopic bacteria. We're finding more and more. They're widely distributed in lakes and in lake sediments. The more we look for them, the more we're finding the potential for blooms to occur. And as we heard, blooms are dynamic, right? Spatially and temporally dynamic. Dynamic in terms of toxin gene expression. Symptoms, human health symptoms are possible with or without toxins even. You know, the lipopolysaccharides can cause, dermal issues and symptoms, rashes and so forth. Bloom formation is difficult to predict, right? We've touched on some bloom formation prediction, but where and when exactly is challenging. And then they're also difficult to remove from a mitigation perspective. There's very few tried and true mitigation techniques. Oftentimes, the more effective ones are have their own potential environmental side effects. I'm thinking some of the copper products that are out there. And then there's also challenges when it comes to characterizing and quantifying lake-wide impacts to water bodies and their uses. Capturing spatial and temporal representativeness is definitely a challenge, and I think some of the tools that were presented earlier are certainly helpful in that regard with regards to satellite imagery. And the figures that I have on the right represent one spot on a lake in two sequential photos over 2 days, one where the bloom was present, and then the next day when we went back to sample, this is going back 10 or so years, the bloom had dissipated and was gone, and no sample was collected, just highlighting that dynamic nature of the blooms. We do a lot of applied research, as I mentioned, within Division of Water and our monitoring programs, and we, as much as we can, use that to inform our programs and evolve our programs based on what we're finding and develop strategies towards HAB mitigation. So first and foremost, back in 2018, during the New York State HABs initiative, we conducted a statewide analysis to understand what the primary drivers and predictors of HABs across New York were. And these are the four primary drivers that we found. The first were dracenid mussel presence, their ability to favorably or effectively avoid filtration of cyanobacteria and preferentially filter some of the more typical green and diatoms present in the water column, effectively help promote the growth of cyanobacteria. Length of lake fetch, right? So how long the lake was a predictor and correlated with the occurrence of HABs. The compass orientation of that max fetch, oriented from the northwest to the southeast, oftentimes is a predictor of HABs. And then phosphorus, increasing phosphorus concentrations, as we heard earlier, are often correlated in drivers of HABs. And of note here, phosphorus is the only controllable primary driver of HABs across the state that we found in our initial analysis, and is one of the elements that's informing our HAB management strategies going forward. And of course, all of this coupled with those factors like sunlight, calm conditions, warm temperatures, creating the prime conditions for HAB formation. Patterns in frequency, intensity, and duration. This is what we would consider one of our more sentinel pieces of literature that we've published in New York State over the past several years, particularly when it comes to HABs. We like to take these looks at our programs, conducting trends analyses, understanding what the trends are, what the management implications are, and how we might evolve our programs in response to what we're seeing. And that's what we did with HABs using this analysis. So looking at the frequency of HABs in terms of the number of water bodies on a given year, and was that increasing over 2012 to 2020? Intensity, so looking at the concentrations of cyanobacteria in those lakes and across New York State during that period. And then the duration, so how long were HABs tending to last? And there was an enormous data set we were looking at, sifting through thousands and thousands of data points, HAB reports, analyses. So it was a lot to look through. And real briefly, I'll go through some of the results that we found from that. So frequency, so in terms of number of water bodies that we saw in a given year, we certainly saw a statistical increase in the confirmed cyanoHAB reports through 2016. So the figure on the left is the figure that was published. The figure on the right is sort of the extended analysis continued beyond 2020 when the data set stopped. But we saw a real plateauing of reports after 2016 or 2017. And we've continued to see a little bit, perhaps, increase on a yearly basis overall in the number of reports that we see every year, or number of confirmed reports on water bodies, I should say. But I think one of the challenges it ends up being is because the growing public awareness of HABs, and this is one of the findings of the paper, is that it's really challenging to separate that awareness factor and the educated public and the reports that we received through NIHABs and other sources, separating that from the actual increase in HABs. So I think that was the finding, is that it's challenging in that, going forward, we need to ensure that we're able to not only monitor using that public awareness, but also incorporate elements into our own programs. CyanoHAB intensity. So we found that there's no increase in open water CyanoHAB intensity as measured using a fluoroprobe and blue-green algal concentrations. One of the major findings, besides that we didn't see an increase in the open water concentrations, were that the shoreline bloom collections, so we did a lot of response sampling historically as part of the HAB program in New York State, was that those shoreline bloom collections were inconsistent, not representative of water body conditions. And by design, they were skims of sort of what we would consider the worst case scenarios, and looking at toxin concentrations and cyanobacteria species, but not necessarily something that we could look at from a trend analysis, and is a big factor in not continuing to do that bloom response sampling that we had done in the early years of the HAB program. And then duration, so looking at the duration of HABs over the study period during using beach closure data. So what we found was that the duration of HABs were not increasing during that 8 to 10 year period. based on that beach data. So what this figure shows is the number of lost beach days per year. And as we saw with the water body frequency, you saw an increase through 2016 or so, but that's lost beach days. And that's during that period of time in which a lot of folks were becoming more aware of HABs and what they looked like and understanding. And we started to see more beaches closed as a result until that, again, plateaued in 2017 or so and remained consistent through about 2020. There might have been a dip in 2020 due to COVID and more beaches closed due to COVID than due to HABs. But the average duration remained statistically no difference, statistically insignificant, and it was maintained about at 8 to 10 days or so during the study period. So no significant change there. So in terms of how we take this information and consider it from a programmatic perspective, we found that we really needed a more deliberate HAB monitoring approach, right? The response sampling was not working. It wasn't particularly efficient use of resource, nor is it effective in understanding long-term trends when it came to HABs. So we incorporated representative HAB monitoring through our core program, the Lake Classification and Inventory Program, sampling at a representative location as part of each sample that we collect through that LCI effort. Continuing, of course, with NIHABs, surveillance and reporting. It was an effective tool, continues to be an effective tool in taking information publicly and reporting it back. Continuing applied research to advance our understanding and management of HABs and understanding what those options are. And then taking both a long and short-term approach when it comes to HAB mitigation. So addressing controllable factors, like as I mentioned, such as phosphorus and our clean water planning efforts, development of total maximum daily loads and so forth. And then considering at the same time, what are the new effective short-term HAB mitigation options for the protection of uses, right? Such as recreation and drinking water. So this is what we came up with and what we've sort of been communicating publicly about how we approach HABs from a holistic perspective. So starting with one, watershed management, monitoring, understanding where HABs are occurring, developing our tool set in terms of phosphorus guidance values. So currently we have out for public comment and review public phosphorus guidance values. That's open through March 11th currently. Clean water planning, as I mentioned, developing pollutant reduction strategies to address phosphorus as a long-term controllable cause. Funding to go along with that, right? Funding to reduce occurrence of HABs through our water quality improvement project program, our non-point source planning and mapping grant program. To date, we've awarded over $530 million to nutrient reduction projects. Researching HABs and their causes, as I mentioned, focusing on prevention, mitigation, monitoring, modeling to understand causes. We've got a HABs research guide out currently, that sort of guides that agenda and provides priorities for research. And at this point have advanced 14 million for research, and then continuing to develop our in-water body mitigation tool set, developing and implementing and evaluating these opportunities we have to help control boom size information. A little bit on the research, current research efforts and accomplishments we've had recently. So the HABs Advanced Monitoring Pilot Project was initiated in 2018, a collaborative effort between several state agencies and the United States Geological Survey. And this effort is really coming to conclusion. A lot of the results and analyses are completed now, and we've developed 2 websites, one through USGS and one through DEC. The QR code here will take you to the DEC Advanced Monitoring Pilot Project Summary page. 11 reports and peer-reviewed papers, several data releases available through the USGS, 1 Master's of Science thesis, and a whole slew of quality assurance plans and other project documents have been generated as a result of this. And then I wanted to also touch on satellite imagery. I know Blake gave a really good rundown on it. And, I think one of the potential applications in New York that we found is for satellite imagery to really provide a broad, and I think he touched on it, unbiased observation of HAB occurrence statewide. Sentinel-2 was touched on as well, provides a fairly high flyover rate, high resolution application that allows us to extend satellite imagery over smaller lakes across the state. And then it takes away some of the observation bias that we noted, it was noted earlier, and that is inherent to monitoring programs and programs that are dependent, as any are, on the observation and reporting of HABs or any other analytical parameter that we're collecting. And real quick, here's an example application of that in New York State. My colleague, Dr. Lewis McCaffrey, has been working on this. And this slide just shows the application of that. Last fall, this happened, this was 2024 on Seneca Lake, and a comparison of the satellite imagery generated through Sentinel-2 compared to NIHAB's reports. So on the left, we have from the 1st of September through the 19th of September, the HAB reports that were reported all along the shorelines of Seneca Lake. A flyover image from the 14th of September and a satellite image from Sentinel-2. And then lastly, sort of all that information aggregated through the Sentinel-2 imagery during the 1st to the 19th, kind of culminating in a snapshot of what happened during that 3-week period in terms of ficlosign and potential HAB concentration. So a lot of information potentially gathered through this approach, right? That isn't as dependent on the reports and can help to aggregate that information spatially and temporally. And then the last piece I wanted to touch on was looking ahead in a HAB roadmap to furthering our management of HABs into the future. Real brief, I think we're probably getting to the end of 20 minutes here, but focusing on continued monitoring and assessment of HABs across the state, development of potential regulatory thresholds to inform HAB management, considering that, planning and implementation of clean water planning focused on HABs specifically, continued mitigation and general research, developing permitting pathways to streamline effective strategies for HAB mitigation, and then continuing our public outreach and reporting programs to ensure that the public continues to be informed of HABs and what's going on out there. And then the last thing I wanted to leave you here with are 2 QR codes for the funding sources that I mentioned earlier. These contain previous awards for the last round, and if anyone's interested in looking forward to future funding opportunities in New York State when it comes to watershed and water quality improvement, these are good places to start looking. So I think this summary, we touched on holistic and long and short-term focus when it comes to HAB management, nutrient reduction and funding to support those efforts, and then continued monitoring, assessment, planning, research, permitting, and reporting of HABs going forward. That's it.
Thanks, Brian. So now I'll introduce our final speaker. We'll be talking about the development and overview of New Jersey's harmful algal bloom response strategy. So this is Chris Kuntz. I hope I pronounced it again. Please correct me if I've done that incorrectly, Chris. So
it's Coons, but that's
Kuntz.
fine.
Okay. So New Jersey's Department of Environmental Protection, Division of Water Monitoring Standards and Pesticide Control. So Chris is the Harmful Algal Bloom Response Coordinator and Bureau Chief for the Bureau of Freshwater and Biological Monitoring within New Jersey DEP's Division of Water Monitoring Standards and Pesticide Control. Chris graduated from Richard Stockton College with a Bachelor of Science degree in Biology. I'm going to go through, and he is currently a member of the Monitoring Advisory and Coordination Committee for the Delaware River Basin Commission and a frequent presenter and co-chair for the New Jersey Water Monitoring Council. Take it away, Chris. Thank you.
Okay. Thank you. So good afternoon. So for this presentation, I just wanted to kind of go through mainly the evolution of HAB monitoring and the HAB response strategy in New Jersey. We came to monitoring for HABs and response later than New Hampshire and New York. So we're kind of trying to catch up in a lot of ways. But due to a lot of things that have happened in recent years, I think we've made some pretty large strides. So I'll go through, just the strategy development, what our response strategy is currently, what our capabilities are, some of the enhanced monitoring that we do, and I'll touch on briefly the, what we saw in 2024 as compared to previous years. So for New Jersey, the first time we collected any kind of toxin samples, algal toxin samples, was in 2007 as part of the National Lakes Assessment. We obviously had HABs before that, but nobody was focused on them. And then we collected, those samples again in 2012. And then, when, the big HAB happened in Ohio in 2014, where drinking water sources were affected. It was kind of a wake-up call for, upper management and DEP. And, my bureau, the Bureau of Freshwater and Biological Monitoring, we were asked to, give a summary of what was going on in the state. And at that time, we had very little information. So we quickly, put together some sampling plans and did some preliminary surveillance around the state just to see if we could find anything. We did collect some samples in 2014. And then, quickly after that, we began building capacity within the Bureau for not only monitoring, but the analysis, and, we include both microscopic and toxin analysis in the Bureau. And then in 2019 was a real turning point. Lake Hopatcong is the largest natural lake wholly within New Jersey. There was a significant bloom there in 2019. There are several beaches present in Lake Hopatcong, one state park beach, and then several privately owned beaches that, as a result of, and I'll say it's a turning point, not because of the HAB itself, but because of, the response. Our strategy was still being formed at that time, and there was some miscommunication, and the New Jersey Department of Transportation put up, digital signs saying that Lake Hopatcong was closed, like the whole lake. And, much like I think Kate mentioned, we don't have the capacity to close any water body. We don't have the authority to do that.
Apologies, Chris. Your slides don't seem to be advancing.
I didn't advance yet.
Okay. Could you also
now?
go to presenter mode? Thank you.
Did it go forward now?
No.
No. Okay. Let me see.
Sorry to interrupt.
No, that's all right. That's good. How about now?
No. Emma, do you have thoughts? Maybe.
No, let me stop. Let me stop sharing and I'll reshare.
Okay.
See what happens. Let's see. Share.
It should be the PowerPoint application.
Yeah.
You're sharing.
You see the slide now?
Yes, but if you go on the very bottom and you see that little presenter mode button, looks like kind of like a little screen on a stand next to the right of the notes. There you go. Yep.
Okay. Sorry about that.
Oh, I'm sorry, Chris, we're still not seeing it. It's still, we could see everything in the PowerPoint.
Okay.
See. Sorry about that. Yeah, it's not in the presentation mode. It's just open in PowerPoint so we could see all of your slides.
Okay. Let me see. Well, let's see. No. It's not cooperating with me.
Chris, an alternative way too, if you go to share at the bottom of the screen, there's option at the top. It says screen or application or file. You may just want to share it as a file if it's giving you too much problems.
Okay. Still nothing?
We're seeing your screen now. We just, again, we're not seeing in presentation mode.
So Emma, we have a copy of the presentation. Should we try it from your end
Yes.
or my end, whatever works?
Yeah, Chris, I can pull up your PowerPoint and you just want to let me know when to advance slides. Does that work?
Yep, that's
Okay,
fine.
just give me one moment here. My apologies, folks. Just give us one moment here. Okay, are folks seeing my screen now?
Yes.
Okay, sorry about that.
At least I am.
Okay, Kathy, are we good? My apologies.
No, we're good. We're good. It's fine. No
Yep.
worries.
Okay, sorry about that. Okay, Chris, just let me know when you want me to advance the slides for
Yeah,
you.
you can advance to the next one. And the next one. So this is where I left off, with the Lake of Patcong. Like I said, there was some miscommunication between DEP and Department of Transportation, where it was, signs went up that said the whole lake was closed. And of course, businesses and mayors from the neighboring towns were a bit up in arms. We did manage to get through that season and, kind of walked back, the warnings, or at least, allayed people's concerns at the time. But that kind of spurred, the harmful algal bloom response strategy in New Jersey. So you can advance to the next slide. So we did have a draft strategy in 2017, and that was between, there was a lot of people involved, including our division, especially our Bureau of Freshwater Monitoring, Parks and Forestry, Fish and Wildlife, Science and Research, Water Supply, and you name it, anybody in New Jersey was involved in at least reviewing this document and, providing input where necessary. So the document itself is reviewed and updated annually. The last major update we had was in 2022. There haven't been any major revisions since, other than updating web links, but we are scheduled to revise it this coming year because there are some changes that have to be made. So next slide. So the strategy, touches on a bunch of different things, just a background of, harmful algal blooms, the human health and recreational risk thresholds. New Jersey decided to go their own route, and the Science Division of Science and Research, they, took a look at literature and, available literature and came up with, slightly different thresholds than EPA in some cases, especially for microcystin. And then there's, part of the strategy is the investigation and response, what the advisories are as a result of the risk thresholds, covers research and it covers elements of outreach. So, and then, when this slide shows shared, then that link will be active. And you can use that web page there, but you can advance the next slide. So these are the current thresholds for New Jersey. Like I said, they're slightly different than what EPA recommends. And these thresholds, they're meant to, just confirm the presence of a HAB. And depending on, these thresholds, these levels here, at least for toxins, result in what we call an advisory. And advisory, if there's a beach involved, then we'll recommend to New Jersey Department of Health that a beach be closed. Not the whole water body, but the beach itself. And in New Jersey, I'm not sure if it is the same in other states, but New Jersey Department of Health is responsible for the closing of any beach due to any kind of pollutant or toxin levels. So, and there are some, elevated thresholds that we include. So those are part of the strategy as well. And we have several different alert tiers. So next slide. So, and this is just in terms of cell concentrations. We consider, a harmful algal bloom at a watch status when cell concentrations are 20,000 cells per mil. And then our advisory level kicks in at 80,000 cells per mil. Next slide. So in terms of, our investigation and response, we also, like Kate mentioned, we use the Survey 123 app for reporting. And, I'll concur with her that it has streamlined reporting quite a bit, because we did, before we started using this app, we were getting, phone calls, emails, text messages. And then for a short period of time, we also got reports through the DEP hotline. So it was, as Kate mentioned, pretty chaotic at first. So this is a much better way of handling these reports and kind of combing through them to determine if we need to sample or not. So, and we currently get somewhere between 340, 400 total reports every year. So, next slide. So one of the other things we developed was the harmful algal bloom dashboard, where it gives, as soon as our analysis is completed, the HAB dashboard website gets updated to give you a current, status on any water body that we've sampled. Much like Kate and New Hampshire, it is a response program. We don't routinely monitor for HABs. It is based completely on reports that we get, or if some of our staff happen to be out near or passing by or at a water body that has a HAB, then they'll, take it upon themselves to collect samples at that time. So, next slide. So again, once the analysis is complete, we determine what alert tiers are appropriate. We then notify upper management, and including the Department of Health if beaches are involved. We send out notifications to, lake managers, local health departments, because they assist us with placing, appropriate signage where necessary. So if it's a drinking water source, which we do, monitor for, a lot of water purveyors, they have their own consultants and own labs that they use. But in many cases, the turnaround time for analysis is pretty long. The Bureau can, if it's an emergency with, as in the case of a drinking water source, we can usually turn around samples, within 24 hours. So, so we are asked to monitor once in a while as necessary. And, we continue to monitor as needed, depending on requests from drinking water supply. If it's a bathing beach and we have a closure, then we institute weekly sampling until that, HAB dissipates or not. And then the other water bodies are resampled. We only go out and resample if they're not a drinking water source or a bathing beach. We only resample if we're given a new report by either, the public or local health departments that indicate a change in the status. If we get no reports, then the status stays the same until, we go out in November and December and do what we consider closeout samples. So in most cases, the HABs have dissipated by that time, but we do have several persistent HABs from year to year. So next slide. So this is just a slide with the current advisories. I won't go through this completely in the interest of time. And like I said, once this PowerPoint is shared, then you'll be able to take a look at that. As far as, like I said, we have several tiers: a watch, advisory, warning, and danger. We've never had any HABs that were in the danger alert tier. We have had warnings, and they do happen, it appears, more frequently in current years. So next slide. So in terms of research, we have a HAB task force that meets, pretty regularly during the year, just to go over any current HABs of note or any kind of updates in guidance. So we meet probably every other month just to make sure we're all on the same page, and that includes several different bureaus and programs within DEP. We do the annual review of the response strategy. We have an annual HAB summit, which is coming up in April, where it's not just, we'll give a summary of the previous year's HABs, but there's also presentations from consultants and academia and lake managers about either things that they're working on or things that they observed during the previous year. So we also have plenty of internal discussions, talking about what changes might be necessary for monitoring and response. And then the state also created a HAB expert team, which is composed of academia, consultants, and other professionals around the state. And they recently put out this lake management guidance, which is really helpful. It kind of compiles like all the different things that lake managers should be looking at and what they should be monitoring for, and how to mitigate HABs or manage them as best they can. But the HAB expert team is there to not only just provide this lake management guidance, but any kind of technical questions that come up that we run into, they're available to help us with those. So, next slide. So outreach, we have, a great, web page that has a bunch of, different outreach materials, from fact sheets to, links to, the annual summit, to the strategy itself, photos on how to identify HABs, obviously contact information. And there are several, training videos that, the public and lake managers can watch in terms of, reporting, just how to report the HAB or suspected HAB using the application. There's a training video on taking phycocyanin measurements with a handheld fluorometer. And then there's also a sample collection training video. So, next slide. So all of our staff are trained to identify and sample HABs. Whatever reports we get, they're all investigated within a week or sooner. If they're, drinking water sources or bathing beaches. And we, After 2019, we added a research scientist position to the staff, specifically to focus on, cell identification and enumeration and research associated with HABs. And I'm happy to report that that's someone that you guys know well with Emily Mayer. We're happy to have her in our state. So next slide. So we use, standard, phytoplankton IDs. And, we do this using hemocytometer, and then those are reported as natural units, as cells per mil. So next slide. We also purchased, 2 automated ELISA analyzers. We had one initially, but because of the amount of toxin analysis that we were doing, we recently purchased a second one. It allows for expanded capacity, but also allows multiple toxins to be analyzed at the same time. So, our typical sampling, and analysis, we'll do cell counts and we'll do microcystin analysis. If microcystin analysis shows that levels are above our threshold of 2 micrograms per liter, then we'll do additional analysis on the other toxins. So next slide. So in addition to, just the sampling and response that way, we do have continuous monitoring buoys. We employ, aerial flight surveillance. We do use the Cyan app, and we have partnerships with a lot of different groups and programs around the state, which is very helpful for us. So, next slide. Like I said, we have 13 continuous monitoring buoys at this time. We also have one land-based telemetry unit that we use in some cases. These are deployed in water bodies that have known HAB history. We're deploying them in these water bodies to gain a better understanding of how HABs form. Again, like everybody else, trying to come up with ways to predict when HABs are going to occur. So we do collect samples alongside the continuous monitoring, so we can use those correlations to help us look at the data from the continuous monitoring buoys and make that more useful. So next slide. So just an example of the page or continuous monitoring page. We use phycocyanin measurements, and like I said, we use those alongside discrete monitoring results to come up with useful ways to look at the data and be able to determine if we should go out and sample at the locations where these buoys are. Next slide. So we also partner with the Forest Fire Service. Between Memorial Day and September, basically beach season. We do weekly flights. One of our staff accompanies a pilot from the Forest Fire Service, doing both visual observations, and we have a hyperspectral sensor that is used to estimate, phycocyanin levels, and then from there correlate that with cell counts that we've also, collected some data on and did some correlations to make that useful information. So like I said, every week we do that during swimming beach season. So next slide. And just go to the next one. Yeah. So we have handheld fluorometers that we use in the Bureau. These were made by Turner Designs, very simple to use. We purchased additional fluorometers and have, or at least in up until this year, have had a loan program where we were loaning these out to partners or lake or beach managers, some of the other DEP staff. So we could use this as a screening tool to determine, again, if we should be out there sampling. So you can see on the right, the thresholds that we're using in accompanying the fluorometer readings. So, at that 20,000 cell count range, that would trigger, us to go out and sample a lake. So, or if one of our staff is investigating and they, get a fluorometer reading of 20, then they know that it's they should sample that lake. Next slide. So, and this is just kind of a history from 2017 through 2024. You can see like there's a pretty steady increase. Definitely in 2019, there was a big jump. And that probably similar to what Kate said, part of this is, the public just being more aware and having more information. And at the same time, I believe that's when the reporting app was first, utilized. So that's the reason, that there was a big jump. But we're still somewhat increasing. I think the interesting part here is that we had this past year 77 reported water bodies and 70 of them had confirmed HABs. And I think that is, again, probably an indicator that the public has become more informed, that the water bodies that are being reported are more likely to have a HAB because people just know more than they have. So next slide. So, and like I said, these are some of the things. We have the HAB Summit in April. And also in April and possibly May, we're going to have we had one lake management guidance training given by the expert team last year. We're going to have another one this year. We did purchase the drone on the left. We purchased it a few years ago. Haven't been able to fully utilize it yet. There was some problems with software that we had to get through. And I think this year is probably the first year that we might be able to fully utilize it. And then we're going to have a pilot study, this year, to determine the presence of, what they call, I guess, the eagle killer, cyanobacteria. That's, in a lot of cases associated with hydrilla. So that's coming. And then, I think going all the way back to Max's presentation about the Sentinel-2, we were recently approached by USGS to work with them on doing some ground truthing for, I believe, my guess is it's the Sentinel-2 satellite imagery. So we'll be doing that. And I believe that is it. And I apologize again for having trouble with my slides.
No worries, no worries. Okay, so I'm going to share my screen to go to the questions session. Hopefully that'll work. Maybe not. Try again. You see my screen?
Yep.
Yep.
Okay, so let's see if I can access. Gosh, no, I can't access chat from here. All right, so I am going to go stop sharing and go back to chat. Okay, sorry about that. All right, so first questions. This is for Blake and Max. Why is the probability set at 2 decimal points? Surely it is not that accurate. It makes it less believable.
Hey, yeah, thanks for the comment. It's a good point. Part of that's just the beta translation of a lot of this was done by hand and cut and paste. So, you know, the model behind the scenes spits out a ton of just geeky information that other people publicly are probably not going to be interested in. And it's just a matter of we just are still working on the public translation. So, yep, duly noted for sure.
Thank you. Okay, next question is also for both of you. Is there any chance of getting to smaller water bodies with a lower pixel size?
Yeah, that's I think where that Sentinel-2 product comes in. So that's gonna again, the current Science Sentinel-3 is at this 300 by 300 meter resolution, covers 2,000 lakes. But moving to Sentinel-2 gets us down to this 20 by 20 meter resolution. So as you can imagine, that opens up just a ton of hundreds of thousands of new water bodies. So that is currently in development.
Okay, very nice. Okay, next question for both of you again is the 2024 forecast data archived online anywhere?
It's not archived online, but if you email us, I know folks have been asking to look through it. And I think our colleagues at Office of Water can like email you the behind the scenes spreadsheet if you want to dig through it. Again, it's just more so because this summer it was very much kind of like trying to make it work. So we just put it on a website that wasn't really meant to do those visualizations because we were just trying to speed through it. So yeah, if you message us, I think the colleagues at OW will be happy to provide that information.
Okay, thank you. So next is a question for Kate in New Hampshire. Is cyanobacteria monitoring free for private lakes in New Hampshire, or are private lake associations responsible for some of the total monitoring costs?
Yeah, the program's totally free for anyone that wants to submit a sample. So
Nice. Okay. Another question for you. For the toxin testing graphic showing an increase over the years, is this greater occurrence or more sampling or both?
yeah, that's hard with our program because it is response-based. We can't really parse out what the drivers are of the increasing frequency of blooms that we've seen. Yeah, I think a lot of it is likely due to some of the factors that we've all been talking about today, primarily nutrients, but and anecdotally, we get people saying, I've never seen these conditions on my lake before. I've lived here for 25 years or whatever. So I do think they are increasing, but there's also the public awareness component as well that we can't figure out with our data the way it's collected. So definitely a great question for sure.
Okay. So we have the same question for Brian's New York data. Is this a real increase or just more looking? Maybe both.
Yeah, I think the response is similar, right? Maybe both, maybe better awareness. But I think to add on to that is, that's why we're trying to incorporate things like satellite imagery and, representative open lake monitoring to try to get a better handle on that over time, where you can remove some of the bias based on, more eyes on the water, more awareness. So it's a great question and something I think we're all working on.
Okay. Another question for you, Brian. The shoreline accumulations statement is the shoreline accumulations may not represent open water. Same results as for 3 papers in lake and reservoir management in 2009, but neither does the open water result represent what many people using the shoreline experience. Need both.
Yeah. I think we've gone to the observation sort of approach when it comes to HABs because we can identify and respond to blooms, or the public can identify and respond to bloom reports on the shoreline. And I think what we tried to highlight through that trends analysis was that collecting the amount of data that we were generating wasn't particularly useful. So the information that was generated, the data that was generated, didn't necessarily have a purpose. So we're looking to more question-based monitoring, and for now at least, that shoreline monitoring, and the response to it being based on the observation. Our response is going to be the same regardless of the presence of toxins. So I think that's, in a nutshell, our approach currently.
Okay, another question for you. How do the dreissenid species lakes compare to the non-dreissenid lakes in terms of phosphorus concentration? For example, are we seeing dreissenid lakes with low phosphorus exhibiting more blooms than non-dreissenid lakes with low P?
That one I'd have to dig in to give a real answer to. Sorry, I can't really.
Oh, that's okay.
Go on.
Okay, next question. What specific research questions concerning in-lake mitigation strategies is the department, DEC, New York State DEC, investigating that are novel compared to other states, provinces, or peer-reviewed literature?
I don't know if they're novel compared to all those things, especially given the progress that's been made over the past several years. But I can mention briefly a handful that we've started working on, and folks may have seen. We've got a publication on electrochemical oxidation, and that that publication will give a lot of detail is with regards to the effectiveness, and I think helps us in particular. I think what's for these mitigation options, that kind of publication and information regarding the efficacy and the byproducts and so forth are really useful in understanding how we might permit mitigation strategies. We've also employed ultrasonic devices. I know there's a lot of literature out on all these, so it's not necessarily different than what we've seen, but it's our own application of some of these mitigation strategies. And unfortunately, we haven't been real successful in getting all of the results out there. But we're certainly looking forward to more demonstration of efficacy using the literature in terms of what kind of strategies are most effective and what we could permit in New York State.
Okay. And the final question we have in the chat is for Chris. So the question is, from sampling to testing to results reported, what is the average time to get results back?
It depends on what type of source it is. Is it from a beach? Is it from a drinking water source, or just a water body that just has recreational access? So we prioritize, drinking water source samples are analyzed first. We try to get those, as I said earlier, within a day if possible. The same goes for bathing beaches, and then for the other water bodies that don't have beaches or not a drinking water source, they may take several days to a week.
Okay. So any other questions? I think we've gone through. Oh, we've got one more question here. Sorry, I missed that. So question for Brian. I am a New York State Park Manager. Do you think that sonic buoys are an effective way to combat harmful algal blooms?
We've not seen a lot of efficacy when it comes to using ultrasonic devices. The literature, I think, would support that for the most part. So, that's my short take, is that the times we've had them out, we've not seen efficacy.
Okay. All right. Any other questions folks had? Okay, so we've got a question for Chris. We've had a lot of talk about monitoring, but what about suggestions? What suggestions does Chris have for decreasing HAB, sorry.
I don't know. That's been talked about in some of the other presentations about, the reduction in nutrients in any way possible. There are some technologies to at least manage HABs, or, there are a lot of these are covered in that lake management guidance that our expert team put together. But in a lot of cases, it really depends on lake conditions. And, what we recommend is that any lake manager has a consultant that they're working with to really take a deep dive into lake dynamics where they are, and they can, then recommend, best ways to mitigate or manage the harmful algal blooms. But, until we get a handle on the inputs, really the non-point source of phosphorus and nitrogen, we're always going to be playing catch up, I think.
Okay.
Hey, Kathy, I think I would add to that, and just echo it also, because I think we're, at the same point where we're encouraging watershed planning and nutrient reductions in concert with some of those shorter term mitigation options, and emphasizing, to particularly our lake communities, that there's no silver bullet and no shortcut to HAB management. So it's important to take that long perspective and develop those long-term plans.
Okay, thank you. So more questions for Blake and Max. When do we expect Sentinel-2 data to be available?
Great question. We want to ask that too. So the pilot project currently includes Ohio, Oregon, and Florida. We expect that to be rounded out and hopefully completed by September of this year. And then we will have to talk to Noah Nesdist, who will be doing all the processing and hosting. And we have to kind of look for funding to kind of round out the rest of the country going forward. So maybe as soon as next year, depending on funding capabilities and hosting. That's a lot of stuff to host and do. And I think it would be very preliminary. It will not be as refined as the current SCIEN project is, because there'll be a lot of quality assurance work we'll need to do in the years to come. So it's going to be a slow progression over the coming years, I think.
Okay, thank you. And then another question, I think it's for New Jersey and New York, similar to New Hampshire. Are all phytoplankton ID and toxin testing services free of charge for private lake associations?
I can answer for New Jersey, and that is yes.
And for New York?
No, we have a list of labs that folks might have access to if they're interested in toxin testing, but we don't do a lot of that ourselves anymore. So no, it's not a free of charge analysis.
Okay.
Yeah, and I'll just add to my answer that again, this is a response program, so it would have to be reported through the app. And as long as it's reported, then we're going to sample and analyze. But,
Okay.
we don't encourage or take in samples that people just collect for the heck of it.
Okay.
Mm-hmm.
All right, final question, I believe, is there is some concern about phosphorus being a limited nutrient in the environment and the risk of running out of it in 50 to 100 years, with many papers written on this subject. We bind up a lot of it in the aquatics industry. Is there any way to release it from those bonds for future use if needed?
It's a great question. I'd love to see some of the literature, because I don't think we run into that question all that often. Our question tends to be, how long is the phosphorus, going to impact our waterways, if we implement reduction strategies now. So that's certainly a different question that we've been asking.
Okay. All right, so I believe I've reached to the end of all the questions. I do want to make an announcement on behalf of New Jersey DEP. So some info regarding some of the HAB management techniques may be covered in the upcoming New Jersey HAB Summit, which will take place April 9th, 2025. Please stay tuned. So now I'll just be sharing my screen briefly. Hopefully that won't. Oops, let's try this again. Okay. All right. So I wanted to thank all of our speakers today for your very informative and thought-provoking talks. So many thanks to Blake Schaefer and Max Beal of US EPA, to Kate Hastings of New Hampshire's DES, Brian Duffy at New York State DEC, and to Chris Coons from New Jersey DEP. Thank you very much. We will be posting, with your permission, the presentations on the NEPM's website, so folks can take a peek at that for additional reference. And I would encourage everyone to register for the next session of the webinar, which will take place on March 6th and will focus on water chestnut management. So thanks, everyone. Have a great next few weeks until the next session starts.
Thank you.